Okay, so we're going to show most of our main products on one slide. It's something that the salespeople here have coined the phrase "everything on the truck" because it's pretty much everything that we've got to sell a customer when we go and see them. So we're going to cover a couple of different areas, and it's going to be around this build, run, manage, connect, and protect any application, any cloud on any device. Something you've probably heard lots of times this last week. So just to be clear, that's app modernization, multi-cloud, digital workspace, intrinsic security, and the virtual cloud network. So we're all going to build all this stuff out on one slide as we go. If anybody's got any questions, then just let me know. And Stephanie, if you see anything in the chat that you think I've missed, just prompt me on that.
You got it.
So I'm going to start with our core stuff, the things that most people have got. So if you go to any of our customers, the chances are it's vSphere and vCenter. And then we've also got the addition of vSAN, software-defined storage, and NSX, software-defined networking and security. And you'll probably know that if we do those three things together, that's what we call VMware Cloud Foundation, or VCF. So a lot of the account managers and systems engineers are busy trying to get people from vSphere and vCenter onto a more modern cloud platform, VCF, by adding vSAN and NSX to that mix. But hopefully that's something you're familiar with, and that's something that you've seen several times before. But that's where we start. And the important thing here is that it's not just called Cloud Foundation, it is a foundation for building other data centers and clouds. And the most popular way to buy those are on hyper-converged appliances, or HCI appliances. So Dell have something called a VxRail. That's just a brand name for the hardware running a combination of products here. So quite often you'll see a customer buy our vSphere, vSAN and NSX products, but they'll put it on a hyper-converged appliance, something like a VxRail or maybe a HP equivalent. And they treat it like building blocks. It's a little bit like Lego, where you can just add more bricks and gain a greater capability or a greater pool. And as some of the servers get older, you take them away and retire them, but you just kind of add with more new bricks and you take away older bricks. And it's a much easier way of managing a platform. And it also means you don't have any big migrations because they're all compatible pieces. So the next point on from that is that we can take this same software stack, this vSphere, vSAN, and NSX, VMware Cloud Foundation, and we could run that on a second data center, which is quite common for our customers because they want to make sure that if the first data center is hit by a flood or a power cut or a hurricane or something like that, they want to have another data center which is geographically or logically in a different location, far enough away that whatever affects this data center doesn't affect this one. So generally, you know, a couple of 100 miles or kilometers would be traditional. You don't want it too far away because the network gets too slow, but you don't want it too close because the same natural event or disaster could affect it in the same way as we did with data center one. So that's what lots of customers have got. Lots of customers are also looking at using something like VMware Cloud. So something like VMC on AWS, which is nothing more than this VCF stack running on servers in the Amazon Web Services Cloud, or Google Cloud VMware Engine, which is this same set of software running on the Google hardware, or Azure VMware Solution, AVS, which again, same set of software, just running on server running in the Azure cloud. So I'll pause there for a second. Have we got any questions so far, Stephanie?
So every customer is going to have the basics, or should have the basics, of vCenter, vSphere, vSAN, and NSX. And then we're taking that technology and building on top of it in order to put it into any cloud or into that second data center.
Yes, so all of our customers should. However, a large proportion of them started off with vSphere and vCenter, and you'll find that in lots of the conversations you have with people, they've got vSphere and vCenter and maybe one of these extra ones or none of these. And really the opportunity is to turn that vSphere and vCenter into VMware Cloud Foundation. And the reason that that's good for the customer is that that's what all the major cloud providers are running to. So it's like a stepping stone to get to a public cloud provider or a hybrid cloud provider. On top of that, we have native cloud, so Amazon native web services, Google Cloud native web services, and Azure native web services. So what I mean by that is they are running Microsoft software, Google software, or Amazon software, rather than the VMware Cloud Foundation set of software. So this is private cloud because it's in our own data center. This is hybrid cloud because it's a combination of private and public. And this is what we call public cloud or native cloud. This is how most people started with public cloud, but they found that there were incompatibilities between the virtual machines they run on vSphere and the virtual machines and containers they run in a public cloud. And then the final option is for people doing SaaS, or software as a service. So this is where you pay to use the service every month or every year, and you have no infrastructure or no hardware whatsoever. So you might view something like Spotify as a SaaS service, or Salesforce as a service, because you just have a web browser or an app, but the bulk of the computing power is operated by somebody else. And that makes up our infrastructure part. And when we talk about consistent infrastructure, we mean that data center 1 and data center 2 are compatible, or data center 1 and 2 are compatible with VMC on AWS, or Google Cloud VMware Engine, or Azure VMware Solution. So we're talking about a common platform that makes it easy to do public cloud and private cloud and hybrid cloud.
So Jason, is VMware Cloud Foundation just the product grouping of vCenter, vSphere, vSAN, and NSX?
Yes. So the only thing to say on it is technically vCenter is still a separate license, but you would logically buy them all together. So if you buy VCF, you'll get vSphere, vSAN, and NSX, and you would have to buy a vCenter, but everybody would do that. I can't imagine anybody. In fact, there isn't really a reason to not buy vCenter with that stuff as well, but it would be 2 SKUs on a quote or a price list.
So it would be VCF SKU number 1, vCenter SKU number 2. Okay.
Yes. Yeah. So yes, you would logically buy them together, but it would be 2 line items on a quote. I mean, it may be that in future we see vCenter rolled into this, because vCenter is the management tool for all of these 3 products. So logically, it makes sense to bundle it in or throw it in. And the other thing we've got is HCX, and HCX allows us to move and migrate workloads between data centers and cloud providers. It's specifically got features for moving to a hybrid cloud, although it can be used between a customer's own local data centers or on-premise data centers. But the main benefit is that it accelerates the network performance between on-prem and cloud, and it can be used to migrate workloads seamlessly, doing things like doing them in batches or doing them live, but also by making sure that the networking still works once it's moved from one data center to another. And what
does HCX stand for?
It stands for Hybrid Cloud Extension, although that's an internal name we use. I don't think there is actually an official name for it, but if there was an official name, it would be Hybrid Cloud Extension. But I think that was an internal name. I'm not sure if you'll actually see that name on any of our marketing. So that's what we do. The other things to add here is there is a built-in feature of vSphere called storage replication. So if you want to replicate your storage between data center 1 and data center 2, you can do that with vSphere replication, which has been in the product for a number of years now for free. So as long as you have a copy of vSphere, you're entitled to use this replication tool. And there's a more advanced version of that called Site Recovery Manager. So replication will replicate the virtual machine, but how you bring those machines back up and do the recovery in a disaster is a manual process. Whereas Site Recovery allows you to create something we call a run book, which is an order or a list or a method of how we recover from a disaster, how we bring things up in the right order, which services are more important than others. And it's also got an ability to test a recovery ahead of time so that you can check that everything is going to work should you actually need it. So replication is free and included with vSphere. Site Recovery Manager is an add-on product, but this is a way of managing that recovery rather than doing everything manually in a disaster. And all of that falls under consistent infrastructure. That's all the places where we can be running stuff. What I'm going to talk about now, slightly above this, will be consistent operations. So this is what we run it on. And the next stuff coming up here is going to be how we manage it. And we've got a central cloud management platform called vRealize Suite. The common or popular products in that are things like vRots and Wavefront. for looking at health, risk, efficiency, and overall performance of applications and services. So VROPS looks at infrastructure and virtual machines and applications and services to an extent, whereas Wavefront is absolutely laser focused on application performance and application health. So they both do a similar job, but this is more focused on infrastructure and virtual machines, and this is more focused on cloud native applications. But they do a similar job, and you could have both, or you could have one or the other. But this is our operational or management of health, risk, efficiency, and waste. We've got a central logging tool and a correlation tool one of the things that IT departments quite like is that when something goes wrong, they want to have a look at all the logs for all the services or everything that changed just before that incident happened. So it allows you to do something called root cause analysis on the basis that if you have an outage, it's unfortunate, but you shouldn't have it again and again. You should get to the root cause of the problem and stop it from happening in future times. So that's a tool called Log Insight. We have vRealize Automation, which allows you to do things like templates and blueprints in a much more organized fashion. So you can create applications and services, and we can do self-serve, where an individual end user can pick something from that catalog and say, I'd like this application or this service, or a developer can say, I'd like a database server and a web server to build a product. So that's automation. And then Cloud Health, again, looks at mostly cost between different public clouds, but it also does do security and health as well. So again, a couple of acquisitions we've done recently where some of these appear to overlap, but actually they are slightly different markets, or sometimes one is a perpetual license installed on-prem, and one is a subscription model as a subscription in the cloud. So for example, most of our customers buy VROPS as a perpetual license and install it in their own data center, whereas Cloud Health is a subscription. It's a SaaS service, one of these, where you pay for it on a month-by-month basis. But they are all part of our cloud management platform, or CMP, you may see it abbreviated to internally. The next thing that we've got then is a number of tools around network and wide area networks. That's what the WAN is. Wide area networks is where you have connections between buildings and cities. And in here we have vRealize Network Insight, which does observability of network connections. So it looks at the traffic traveling between virtual machines and switches and data centers. It can also be used to help with security groups and security policies for things like microsegmentation. But this is basically a visibility and observability tool for networks. The next one then is VelaCloud, which was an acquisition we did a couple of years ago that accelerates connections between wide area networks, this one part of the description. So this increases the performance of the network between a data center and a cloud provider, or a data center 1 and data center 2. It can even be used for things like home workers. There are smaller VelaCloud appliances, which a user would have at home on the home broadband, but essentially it's a way of optimizing performance and accelerating network and internet connections between offices or home locations. And then the next thing we've got here is Avi, which is a load balancer. This is something that receives all the traffic for a particular application or service and then directs it to relevant servers behind it. So everything hits the load balancer, and the load balancer distributes the requests out equally amongst lots and lots of web servers or application servers behind it. So it's for dealing with high throughput or high performance applications. A good example of a load balancer might be something like Black Friday on an online shopping store, where for a period of time they have massively more connections than normal. They would use something like a load balancer to distribute all those requests over a number of servers behind them. And when it's the following day and things are quiet, you reduce the amount of servers at what we call the back end, and the load balancer just distributes requests between the normal set of servers or fewer servers. But it's basically a way of steering traffic, usually to a web server or a service. Any questions on any of that for everyone?
Yeah. What is the difference between VelaCloud and HCX as far as moving information between data centers?
Okay, so HCX is a high-speed way of moving information between your own data centers for purposes of migration or splitting load between sites. And usually you'll see a load balancer used between an end user or a customer and the big servers at the back. So the AVI load balancer works a little bit like a receptionist in a building. Everybody comes and speaks to the receptionist directly and then gets directed to the correct place. It does a similar kind of job for internet traffic or application traffic. Everybody connects straight to the AVI load balancer, and then the load balancer directs them to the correct server or data center or application. So I guess it steers traffic is probably a good way of putting it.
Whereas HCX is just the data moving from data center to data center internally, whereas VeloCloud and AVI are more inputs coming into our customer systems.
Yes, if you think about internet connections, lots of people think about internet connections like pipes or plumbing. And if you think about the amount of water you can get down a pipe in your house compared to the size of a pipe under the street or a fire hydrant or something like that, it's a way of increasing the amount of flow or traffic between places. So it's like making your pipes bigger, you know, in your house or in the street or on a fire hydrant, so that more information or more water can flow through at once. So it's an acceleration technology. Does that make sense? Does that example work?
Yes.
Yeah, so it increases the flow of traffic like a bigger pipe would do for water. The next things then are modern applications. So things like containers, something commonly Docker would be the most popular kind of container. So that you'd see something like a Docker container. You also see things like Kubernetes, which is a way of managing containers at scale. So some people have made a reference to the fact that Kubernetes does for containers what vCenter does for VMs. It's the way that you manage lots and lots of containers. And when it comes to containers and Kubernetes, we have a family of products which we call Tanzu, which are all related to applications and developers building modern applications or cloud native applications. So Tanzu isn't an actual product, it's the name of a family of products. Any questions on any of that?
I've unmuted Tim's line. He's got one more question around HCX versus VeloCloud. Tim, I've unmuted you if you'd like to dial in.
Yeah, thanks, Steph. I get your analogy with it increases the flow of the pipes. It used to be that I was a plumber back in the day, so I kind of get that, but I forgot. I lost track of which solution did that. You went back and forth so fast, I kind of lost the handoff.
So HCX accelerates the performance of the network, usually between your own data centers. And it's often used for migrating virtual machines from one data center to another. So it's really a migration tool that has some way of accelerating the performance of the network. Whereas VeloCloud is a constant acceleration tool for speeding up internet connections. So your connection to a public cloud or Office 365, or possibly even from your home broadband if you're working from home to the office. So I'll just move on to my next one, which is Bitfusion. And this is a way...
Hold on real quick.
Oh, sorry, go on.
I'm sorry. Give me 1 second. Martha, you threw a question in the Q&A of what makes it modern. I didn't know what you were talking about, so I'd like you to clarify that question for me.
Okay.
So it's funny, right? So inherently we all know this at VMware, but a customer asked me that the other day and like, well, what is a non-modern application? And I was a bit embarrassed because I couldn't effectively articulate it.
Okay, so I'll give you a simple way of thinking about this. If you have an application, so let's say a legacy application or an older application, generally if you've got an older application, if any server or piece of equipment fails, the whole application crashes or breaks. Because the application expects a bulletproof server or infrastructure underneath it in order for it to work. Modern applications or cloud native applications generally are spread across multiple virtual machines or containers, and they expect that at some point the cloud provider or the hardware might fail, and they've got this ability to kind of look after themselves. They're more robust than fragile. So a good example is if Netflix had a server that crashed and broke, you wouldn't expect all of Netflix to go down for everyone. You'd just expect that they'd have less capacity for a while. Whereas on an older application, when the server breaks, sometimes that application can be broken for the whole day or for the whole week. So it's almost the resilience of the application and whether it can cope with individual failures.
Thank you. So could I say something as simple as that it automatically fails over with like invisibly behind the scenes?
Yes, that it's designed to recover from failures. There is another way that some people describe it, and it's a kind of an interesting thing that developers use. They say that people treat old applications like pets. That if you have a pet, you know its name, you love it, and you care about it. And if something goes wrong with that pet or breaks with that pet or it has something ill, you take it to the vet and you do whatever you can to keep that pet alive. So that's how we think of legacy applications. When you think about cloud applications, people think of them like cattle, like a farmer might do. If a farmer has 100 cows and one of them gets ill, or has an accident or something goes wrong with that cow, and the farmer thinks that maybe losing one cow isn't terrible because he's still got 99 left, and certainly wouldn't pay thousands of pounds to take that cow to a vet and to get that cow made better. So cloud native people think of cattle, as long as I've got enough applications running, I don't care about any particular one. Whereas legacy applications, if that one application breaks, there's probably tens or hundreds of people that can't work. So pets and cattle might be a way of thinking about it that your customers are already familiar with.
I love it. Thank you.
Yeah, I mean, can you imagine a farmer paying £5,000 for an operation for a cow?
Not unless it was the only steer in the group.
Yeah. Can you imagine somebody paying £5,000 or $5,000 for the family cat or dog?
Absolutely.
Oh yeah.
So they basically build in this kind of herd thing where none of the individual cows are so critical that it breaks, and they deliberately have lots of them so that if electricity goes in a data center or a cloud provider fails, the system is able to carry on. So it's this kind of fragile application and robust application. And the difference really is that cloud native developers and modern applications expect failures to occur, and they just handle them more gracefully.
Perfect. Thank you so much.
That's right. And what we can say is it is possible to run a cloud native application in a legacy data center. It's just that the hardware usually has been over-engineered to a level that the application doesn't need, because the application can survive, smaller failures. A good example of this actually is something like Netflix, where every customer gets their own little virtual machine or container when they connect to Netflix. And every single customer that connects to Gmail gets their own individual virtual machine or container. And the reason that Google and Netflix do that is one container failing only affects one user rather than the whole of Gmail or the whole of Netflix. So they work on this model where no one application is so critical that everything breaks around it. Does that answer your question?
That's awesome, Jason. Nope, I've got a couple coming in, but I'm going to wait until the end to answer those. So you keep it rocking and rolling.
Okay, so the next one is Bitfusion, and this is specifically about the computing power in graphics cards. So back in the day, graphics cards were only ever used for playing for computer games or for things like end user computing and VDI. But more recently, graphics cards people have found are particularly useful for artificial intelligence and machine learning. So lots of people want a graphics card in a server for artificial intelligence and machine learning, but these things are incredibly big and get incredibly hot. So it's not always possible to put a graphics card in an existing server. So this technology is a company that VMware acquired, which allows you to put lots of big graphics cards in new servers, but make them magically appear as if they're in your existing servers or shared between multiple users. So it's a way of taking all the computing power in the graphics card, but spreading it around other VMware servers or VMware virtual machines, either so that it's utilized better because it can now be shared out, or because it's just not physically possible to get these big, heavy cards or these big cards that get very hot to put them in existing servers. So it's a way of effectively stretching graphics cards over the network so that an application thinks it's got its own graphics card. And that's what we call Bitfusion. And you'll see it more and more in things like artificial intelligence and machine learning. So any questions on any of that stuff on that line?
Not on Bitfusion. I've got a quick one on containers. So does containers mean a personal virtual machine?
It doesn't mean that, but most companies like Netflix and Google give each end user their own container because it reduces the amount of stuff that breaks. So if Google had one application for Gmail and it crashed, there'd be millions, if not billions of people that couldn't get email. Whereas if Google creates 1,000 containers or 1,000,000 containers, when one container crashes, it only affects one person. So a container is just a way of breaking an application up into a smaller piece or more pieces. I mean, that's
so if something breaks, it doesn't affect everybody.
Yeah, it's a bit of an oversimplification, but what we're really saying is because containers are so small and so efficient, you can afford to give every end user one of their own.
Okay, that makes sense.
Does that make sense? If we have a bit of time at the end, I'll show you another diagram, that shows you what's in a container as opposed to what's in a virtual machine, but we'll just see how we are for time on that. Or what you can do is you can have a look at my videos on YouTube about containers, Kubernetes, and mission control. I do a light board that shows you what's the difference between a virtual machine and a container. Maybe that's a better way to go.
Definitely. And guys, I'll throw that link for Jason's YouTube channel in the chat window. And Tim wants to know if containers and microsegmentation are the same thing.
Okay, so microsegmentation is breaking an application up into smaller pieces so that it's easier to manage and maintain. So that's what microsegmentation is. Containers are a way of creating smaller versions of an application with just the minimal amount of code or a minimum amount of bits inside. So they are separate things, but the way that most people do microsegmentation is by using containers because they're complementary. If you want to break things up into smaller pieces, and containers are fantastic for things that have been broken up in smaller pieces, they often get used together. So they are independent, but they are a perfect marriage or a perfect couple because they help each other.
Got it. Cool. And guys, here's Jason's YouTube channel in the chat window if you guys want to go ahead and bookmark that.
Do you want
and
to take another
Ozzy wants to know, say again?
Yeah, sorry, go on, let's take another question.
Is this the reason why multi-tenancy is implemented?
Okay, so multi-tenancy is when one organization or one entity is responsible for the platform, the hardware, the infrastructure, but multiple customers or end users share it. So a good example of multi-tenancy is actually something like Gmail. So Google own the platform, but when you get your little container with your own mailbox in it, multiple users are sharing the same platform, but they all only see their own stuff. So multi-tenancy is like it sounds like in a housing apartment or a block of flats. You can have there's one building owned by somebody, but smaller pieces of it are individual or personal, if that makes any sense. So it's the ability for a cloud provider to give everybody their own piece of cloud and it all look like they're the only person using it. But multi-tenancy works the same way as it does with things like housing apartments or blocks of flats.
All right. I think we answered that. Ozzy, let me know if you need Jason to clarify any further. And if you're cool, let's take another one since we're making pretty good time today, guys. Yeah. Is it common to see an infrastructure based on either containers or virtual machines? Or is it fair to say that they can have both? Okay,
so it's yes to all of those things. If you're an organization that wants to start a company right now, it would be crazy for you to go and buy lots and lots of servers and build a data center and do all those things in VMs. You would absolutely start building things in containers straight away. And you would probably, if you're a new business, try it in the cloud and see if it works before you spend any money on buildings and infrastructure. So if you were starting an application, a new company starting a new application, absolutely do containers, absolutely do the cloud. If you're a bank that's been around for 40 or 50 years, the chances are you've got thousands of applications that were never written for the cloud, never written for containers, and they are probably all now running on virtual machines. So Older applications or legacy applications almost definitely running in virtual machines. Newer applications and newer companies almost definitely all running in containers. And the bit where you get the difference in the middle is where you have somebody like a bank or a company that's been established for a number of years that wants to run virtual machines because that's what pays the bill and that's what pays everybody's mortgages. But they also want to move into containers and they want to do both. So basically, when you look at something like Tanzu and our modern applications platform, what we're really saying is the bulk of your income comes from virtual machines and the bulk of your applications are in virtual machines, but you'd like to move to containers. We have a platform that can support both. So it's really for existing businesses that want to move to containers, but still need virtual machines. So you can be anywhere on that journey, but I would say if you were starting up something like Airbnb or Uber, you know, you probably would just jump straight to containers and cloud because you don't have any legacy behind you.
Awesome. Thank you, Jason. Now we've taken a good bit of questions on containers, modern apps, Fellow Cloud, HCX. So before we move into that top line, could you do me a favor and start from the beginning, do a quick move through to how we got to the digital workspace, like 10, 15 seconds.
How do you mean?
Level the playing field. I myself have gotten a little lost in answering the questions. So if you could do a quick recap of we're going from data center to cloud. This is how HCX works, and then move our way through the cloud management platform, network, modern apps, and arrive at digital workspace, and then we'll close out the presentation.
Okay, so this is how you build it and how you run it. This is the infrastructure, and it can be your own infrastructure in your data center or a cloud provider or even through SaaS, but this is how we build it and how we run it. This is how we operate it and manage it. So this is more operational style of things, maybe except Bitfusion there, but this is more operational. And I guess what we're saying is the only reason that anybody builds something and runs something, and the only reason that they really want to manage it and monitor it is because we need to deliver it to an end user. So this is how we get applications to end users on mobile devices. We use things like Horizon and AirWatch to get that application or that service to an end user. We use something like Carbon Black to secure those endpoints. And when we want to do nice things like single sign-on and identity management, we can also do things around Workspace ONE. But most of this is IT departments building things, IT departments managing things, and these are more focused on the end user that consumes those services. I think there was another question in there, was there, Stephanie?
No, that was just Rodrigo saying that this was by far the best VMware presentation he has ever watched. So.
Oh, good. Good.
Hats off to you.
Yes, so this is about getting those things to the end user. And you could argue that if you don't deliver an application or a service to an end user, it's actually pointless doing any of this stuff, because businesses don't buy IT and don't buy equipment just for the sake of having technology and new stuff. It's this that actually businesses want to do. And it's this that we're actually selling things on now. We're not selling on gigabits and megabytes and, you know, kind of milliseconds anymore. We're talking to people more about what this does for the business or for their end users. So this is the part where we actually deliver something tangible to the business, because actually down here, this is mostly a cost. And when we get further up here, this is when it becomes value. But yeah, this is about delivering stuff to end users. So again, you know, getting it to a mobile phone, to a laptop, to a thin client or whatever it is. This is more about securing it. And this is more about doing single sign-on, identity management, and that kind of, you know, one place for all your applications, like an app store for the cloud. So this is like the iTunes or Google Play app store, but for enterprise applications. And I guess if you've all been here a while, you're all used to Workspace ONE, and you can see how you just go to one place for everything that you might need. And then we're going to put some services on top. So some of these are people services, and some of these are things that can help customers with the VMware platform. So the first thing we've got is validated designs, or VMware validated designs, VVDs. This is an instruction manual for building VMware solutions. And these are created by VMware certified design experts, of which there are only 250, maybe 300 of those in the world. So you get a design or a blueprint on how to deploy VMware technologies written by some of the world's smartest people. And these are free. So customers can download these look at these and decide to build it themselves if they want to, using a recipe that's been approved by some of the world's smartest VMware people.
So would you say it's for the folks who are more of those, oh, I can build this myself. I've got brilliant people in my IT department. They can figure this out.
Yeah, there's a couple of different things here. Some people will follow them from start to finish. Some people will get VMware to deploy them this way or a partner to deploy them this way. But actually, one of the things that a validated design is most useful for is, let's say we've got a validated design for running Microsoft SQL Server, version X. Some people just want to know that the software they want to run has been certified and it's an approved thing. So sometimes it's a comfort factor. The other time, and the most common thing that I see, is that people go and design their own environments, but they want to check what the official design does just to make sure they've not done anything too stupid. Because if their design isn't too far away from a validated design, then that gives them some confidence that they're not doing anything crazy that's going to cause them problems later on. So I guess it gives people comfort and confidence, although some people do absolutely follow them to the letter.
Interesting. Thank you.
The next part along from that is education services. So this is all the VMware certifications and training. So things like VMware Certified Associate, VMware Certified Professional, VMware Certified Advanced Professional, and then that thing I talked about before, the VMware Certified Design Expert, VCDX. There's only around 250, maybe 300 people worldwide ever pass that exam. That really does kind of mark you out as being a world-class engineer or a world-class architect. But as I say, it starts with things like VCAs, which you could potentially, learn over on an evening or over weekends if you wanted to. It's a basic introduction to VMware products and services and what problems they solve. The next thing we've got is something called advisory services, and this is where there is a specific group of people inside VMware who will go and talk to a customer about the customer's business strategy in general, about which areas they should be looking into, which areas they should be investing in, and it's basically the strategic direction of the business. So an example I would give here is, imagine you've got two companies, you've got Blockbuster Video and you've got Netflix. It didn't really matter how good Blockbuster Video's data centers were and internal systems were, they'd kind of gone off in the wrong direction. Whereas Netflix had predicted the way that consumerization was going to work, internet connection was going to work. And you could argue that the reason that Netflix still exists and Blockbuster doesn't is actually because the strategy was right or the strategy was wrong, not how good the computer systems were. So advisory services talk more about the strategic direction of the business first, and then what VMware products and services could help them. So that is a free service, but you do have to do some work up front, and it does have to be a reasonable sized account. But it's us giving advice on whether the strategic direction of the company is sound, and then which VMware products and services could be used to help them on that journey. The next one is customer experience and success, and it says it in the name. This is about making sure that customers have a good experience with our products and they have success, so that hopefully they will buy more of our products and services. It's a new name, but we've been doing this for a while, and I think the new name for this, Stephanie, is it Success 360 now we call this?
So Success 360 is kind of like the program around launching this new section of VMware. The roles within customer experience and success are success executives and the customer success managers and TAMs.
Okay. The next thing then is PSO, or Professional Services Organization. So if you want help building something of your own design, or one of these validated designs, or you want somebody else to tell you how to do it, this is basically the ability to pay VMware employees to do the build and the design of a platform or an environment for you. What I've found in the past is that PSO works best when it's done with the customer or alongside the customer, because I have in the past seen PSO go in and deploy something, and because the customer wasn't involved or engaged in it, they just treat it as the thing that somebody else built or somebody else's platform or somebody else's problem. So this works better when we're doing knowledge transfer and working with the customer so that they take over the responsibility for the platform. But this is basically VMware personnel or VMware staff delivering our products or installing and configuring our products for a customer. And then the next bit is GSS, Global Support Services. This is the telephone support or electronic support and help that comes with our maintenance agreement. So if you pay for subscription and maintenance or your kind of ongoing maintenance, you'll get entitled to new versions of products, but you also get access to our global support team, which work around the clock in a follow the sun type manner. So this is somebody on the end of the phone who can help you with a technical problem, and depending on the level, they may even be able to give you advice ahead of time, or they may even be able to anticipate problems before you have them, but it all depends on what level of support you've got. So I'm going to pause there, Stephanie. Are there any questions on any of that?
Not on services, but before we move into the quiz, I'd like for you to touch on the Carbon Black piece. I think I even had that question for you when you were building these slides. Carbon Black is part of the Intrinsic Security franchise. Why do you have it listed under Digital Workspace?
Okay, so this is the bit that can do security of endpoint devices, or the devices that the users have in their hands. Now, it does work in the data center too, but I guess it's most visible on the users' computers, laptops, mobile devices, and tablets. So it is a complete end-to-end. We've got visibility across everything, but because this is where customers see it or they recognize the name, I've put it more here because it is a change in the way that we do security, and I'll explain. I'll give you a bit more detail on that. So if anybody remembers the early days of antivirus, an antivirus piece of software would have a list of viruses that it checked for. And in the early days, there might be 500 viruses or 1,000 viruses or maybe 10,000 viruses. We're now at the point where there are, and this sounds like a crazy figure, there are 500 million viruses in circulation. So for a piece of software on your laptop to check every file for 500 million different types of viruses or malicious software just becomes unworkable. But this is what most antivirus tools do. Now, what Carbon Black did, and they changed the industry with this, is they do something called next generation antivirus. And instead of looking for bad things on your system, they look for what a good or a clean system looks like, and they look for changes in behavior or changes in files from a good system. So I guess what we're saying is, instead of running a barrage of tests against your computer all the time, it tries to maintain a good or a known state. Does that kind of make sense?
Yeah, that's probably the clearest I've ever heard that explained.
Okay, well,
Thank you.
I'll give you an even better version of that. Let's say that your child has caught the flu or a cold or something like that, and is feeling unwell. If you took your child to a doctor or a nurse or to a hospital, they'd probably run a series of tests to see if there was anything wrong with your child. Now, if you had the same child with its mother or father, the mother or father wouldn't need to run a barrage of tests. They would just know what their child was normally like, and they would know when something was wrong or something didn't seem right. So the hospital or the doctor or nurse would run a series of tests, but a parent, somebody familiar with that child, would look at the child's behavior. So Carbon Black does the same thing. It looks at the behavior of an application to see if it looks right or to see if it's changed, rather than run it through a barrage of tests. That kind of makes sense?
Definitely.
Yes, because I think most parents know that there's something wrong with the child immediately without having to run any tests or run any checks. They just know that something's not right or something's different. The child is different today than they were yesterday. So it's that behavioral analysis rather than running a barrage of tests constantly on applications and services. So that's what's different about Carbon Black.
Awesome. That was a fantastic analogy. Thank you, Jason.
So are we any more questions, or do you want to jump onto the quiz?
Keep the questions coming if you guys have them. If anything, I will put them in a nice little bucket and send them over to Jason once we are all said and done here today. But go ahead and progress the slides so we can take our quick quiz and get you guys out of here for the rest of your day. So quick answer for
We've only got one more. It was just another intrinsic security. And just by saying that security is built into all this stuff, it's not bolted on afterwards. VMware is becoming a security company, not just a hypervisor company. So I'll pause it there.